Let's take a look at this limit. As x goes to infinity, e to the x goes to infinity, and x goes to infinity. So their sum also goes to infinity. So what the form of this, the base of the exponent, is going to infinity. And when x goes to infinity, 1 over x goes to 0, right? 1 over a large positive number is a small positive number. So this is the form infinity to the power of 0. And that's an indeterminate form. That means we should probably try to use L'Hopital's rule. But we need to rewrite it though, because this we need a form like 0 over 0 or infinity to use L'Hopital's rule. But there's a standard trick to do this, right? Remember that a to the power of b can be written as e to the power of b ln a. Right? We've talked about that before. And that's a really useful trick to change something like this into a form where L'Hopital's rule can be applied, right? So let's try that. Let's just get rid of this. So let's see what happens. When I rewrite that, using that little trick I just mentioned, kind of like I'm taking a to be e to the x plus x, and I'm taking b to be 1 over x. So it's going to be e to the power of 1 over x, that's my b, times ln of this stuff here, e to the x plus x. b ln a. So that's the start. Why don't I just rewrite this a little bit differently? We can write ln of e to the x plus x all over x. That's fine. And now the idea is I can bring this limit up into the exponent, right? So I have limit as x goes to infinity of ln e to the x plus x all over x. Now, I want to, I don't really like writing e to the power of this every time because we're going to have to do several steps of work on this. So I just want to, for now, let's rewrite this limit by itself, forgetting about the fact that it's an exponent on the e, and we'll come back to it later. So we'll leave this for just a moment and just look at that limit in the exponent. Now, what is the form of this limit? Maybe let's see if we can use L'Hopital's rule on it. Well, like we said, when x goes to infinity, e to the x plus x also goes to infinity. And ln of large positive numbers does give back a large positive number, right? So the top is going to infinity. And of course, the bottom is also going to infinity. So we have infinity over infinity, so we are allowed to use L'Hopital's rule. It would be, what is the derivative of the top? 1 over e to the x plus x times the derivative of e to the x plus x, which is e to the x plus 1. So that's the derivative of the top, and the bottom derivative is just 1, right? So that's fine. Let's see. Why don't we simplify this a bit? We can just write this as e to the x plus 1 over e to the x plus x. Now, how can we make progress on this? Well, this is of the form infinity over infinity again. I guess we could use L'Hopital's rule one more time. It's not really necessary. We could just factor out the highest power or the most dominant term from top and bottom. Why don't we do it like that? Let's factor out e to the x from the top. So we get 1 plus 1 over e to the x. And we'll factor out e to the x from the bottom. So we get 1 plus x over e to the x. And then those two would cancel. And Actually, you know what? I don't want to do it like this. It's fine. The answer would be 1 plus 0 over 1 plus 0. But to do this limit properly, we'd have to use L'Hopital's rule again anyway. So I'm just going to, sorry about that. I'm just going to backtrack there. So let's use L'Hopital's rule again. We're allowed to because the form of this one is infinity over infinity as well, right? So I can use L'Hopital's rule again. The derivative of the top is e to the x plus 0, or just e to the x. The derivative of the bottom is e to the x plus 1, right? And, well, I could factor out e to the x now and it would work out just fine. Why don't I even do it again? Because this is also the form infinity over infinity. So we could do L'Hopital's rule again. The derivative of e to the x is e to the x. The derivative of e to the x plus 1 is e to the x. And now we have something good. Because these e to the x's are going to cancel now. And we have the limit as x goes to infinity of 1. And the limit of a constant is just the constant, right? So we've just proven that this limit here goes to 1. But remember, that's not our real question, right? Our real question was back here where we wanted to do this limit, right? And so what we've just proven is that this exponent here, this limit in the exponent goes to 1. So our final answer is going to be e to the 1, right? Why don't we do that down here? We'll just cheat a little bit here. Let's conclude our question. So our question is equal to e to that limit, which was 1, right? Which is just e. So there we go. The answer for this limit is e.